And saying combined, I mean, hey, this is not going to take you long. So we want to use two things. We want to do two things with this. We want to be able to evaluate and solve using graphs and technology. So if I'm given a graph, we just have to interpret this graph. If we, based on the graph, f of 5 equals what? Well, what does that mean? Really all this is about is just, what does that mean? F of 5. What is that?
The y value when x is 5.
Yeah, we're just evaluating, right? We're evaluating the function when x is 5, when the input is 5. So if we go to 5, there's the point on the graph with coordinates 5 and what, 4? So what's the answer? 4. Right? No biggie. Okay, what about this now? This time they're giving us a different kind, gives an absolute value graph. We'll talk about absolute values a little bit tomorrow. So based on that graph, it says solve the equation f of x equals 0. Okay? So how do we interpret that? Yeah, right. We want to know when does y equal 0, right? So we can just, in this case, we can just intersect the blue graph with a horizontal line at y equals 0. So I could change the value to anything I want to. In this case, it's 0, but what if it said 5? Whoops, if it said 5, that would be the horizontal line. What would the solution be? No real solutions, right? There's no intersection. A physical intersection corresponds to a real solution of an equation. So what's the solution going to be there when x is 0?
3.
3. Yeah, and in this case, it's because there's the point with coordinates 3, 0. Well, there's the 0 that we're talking about. And so the answer is all the x coordinates where that happens. What if we wanted to know when f of x equals negative, what's a convenient one right there, I guess, looks pretty good, negative 6. What would the solutions have been? 0 and 6. Everybody get that? Okay. So it's just interpreting, you know, what does this mean in terms of the math that we've talked about, functions. Okay, so now the other 2 or 3 that we'll look at are just using a graphing utility to solve an equation. Okay, so they give us something. We don't really know how to deal with radicals yet. That's coming up later. But how do we evaluate this function? Well, I guess we could probably do this. How do we evaluate this function at 4? Well, we're just going to pull up Desmos. And that's what that button will do for you. It just pulls up a little Desmos and a pop-up. So we would just define this, and the nice thing about Desmos is we can define this as a function. So f of x, equals negative, and then how do I get a cube root? Do you know on Desmos? You just go down. You could, I mean, you actually could do that, but you can just go down to the functions, and you can choose this guy right here, nth root, and then just type a 3 there. Right? That's the index of the radical, just sits on the radical. It tells you what kind of root you're taking. So cube root of x plus 3 divided by 2 minus 4. Okay, so there's our function, and we want to evaluate it at 4. So there's the function. We don't even really need the graph. All we're going to do is just f of 4. And it tells us the value right there. And it just presumably wants this rounded or something. You know, it's good. What's it want? Rounded to the nearest tenth. So that's negative 4.956. What's it going to be? Negative 5.0. Yeah. Okay. Okay, how about this? Now we want to find all the real solutions of this equation. So what are we going to do? How do we do that using technology again? How do we find solutions? Remember? No, we just want to find the intersections, don't we? We want to know where does this function, call it f of x, where is its value, meaning the y values, where are they equal to -9? Okay? So we can graph the left side of the equation in as one function, as one graph. And then we'll graph the right side as -9. There it is. And we're just going to look for the solutions. Well, where do they cross? Nowhere. So there are no real solutions, right? Now, what if that said instead, what if that said something like 5? Well, then there'd be 2. There's one there, and there's one there, right? Okay, so what would the answers be in that case? 1 and 5, because we're solving an equation for x, right? So we want the x values that make that true, okay? Same kind of thing here, just a more complicated function. So 3, there's a shortcut for square root. You can just do SQRT for a shortcut for square root, and it pops up a radical. Okay. So I'm not seeing it. I got it. There we go. Right there, right? Okay, so 6.1. Now, what's another way, and that's fine to just rely on that method, but what's another way I could do this? I want you to see this. I think we talked about this a little bit. I could graph these separately. So this is going to be our red graph, and that was our green graph, right? I could graph them separately, or what else could I do? Okay, so I could subtract 10 from both sides. Right, put this into a standard form where it's equal to 0. So I get 3 times the square root of x plus 1 minus 8 equals 0. And watch what happens. And not surprisingly, if I look for the x-intercepts, they're at the same place, right? That makes sense? So take your pick. Maybe try one of each. Just get familiar with it. We're going to be doing a lot of stuff with graphs in the very near future. So it just gives you a chance to kind of familiarize yourself with this. All right. You may have the rest of the period to work on that. New stuff tomorrow.